Hey everybody, this is Larry. This is April 2nd, technically actually April 1st in New York. I don't know why it's a second, I guess it's day 2 of the Leetcode, just me doing a bonus question, so definitely stay tuned. Hope everyone's having a good April Fool's, I guess, or just a good weekend in general. So yeah, so let's do a prompt I haven't done before, and that's premium, and let's RNG it. We have about 700 prompts left that we haven't done, so we'll just get one. And today it's going to be 2198. Number of single divisor triplets. It's a medium premium. Yeah. Okay, so you're given a nums array. A triplet of 3 distinct IJK is called a single divisor triplet if nums of I plus nums of j plus nums of k is divisible by exactly one of these. There's 10 to the 5th number. There's only 100 numbers. I think the easy, it's not, this is a very hard problem, just to be clear, but I think the easy part is just looking at the constraints. I think the general form, this is not easy, but seeing that nums of I as you go to 100 means that you can do 100 cube algorithm, right? I think that's really the only thing. Yeah, and then you could just brute force it, right? So basically, for example, you can do something like okay, so C is counter is you go to collections dot counter of nums, right? And then now we have for I in range from 1 to 100, right? And then for J is in range 1 to 100, and then for K is in range of 1 to 100, right? Do I want to do it this way, or does it? Or I'm just trying to think whether this makes more sense, or this starting from J and K, because I'm going to do some maths, I think. Let's just do it from 1, 1, 1, I guess. For now. I don't know how I feel about this actually. There's a lot of special cases, but I think this is like some variation of this will be okay. Right. Yeah. Sorry, I'm just double checking reading it. Well, if I plus j, if nums of I plus nums of j plus nums of k is the same, then by definition it is not. This is not true. So, but I don't know what happens if 2 of them are the same. Okay, well, I don't know, but the structure is going to be right. I have to think about the edge cases with around duplicate numbers, and how to handle them really correctly. Yeah, and actually they even tell you this later, but okay, right? So let's just say S is equal to sum is I plus J plus K if S mod I is equal to 0. Something like this, right? If how do I write this in a good way, right? Without abusing something like for x in s mod x is equal to 0. Something like that, maybe is equal to 1. Then now you just add up, counter. We add it to. Oh, sorry. That's not it. But yeah, total 0, and then total is going. And this can get actually pretty big, but before, like we said, we're in Python, so we're okay. But this is going to be counter sub I times counter sub j times counter sub k, right? But of course, this is only true if all the numbers are distinct. But let's give it a spin for now and then see. I don't expect this to pass because of example 2, but I just wanted to see real quick. Apparently there's another case where that's wrong. Yeah, just double counts for that reason because that's fine. We can figure it out. But this one, I actually didn't expect that. There's one triplet, two triplet. Maybe I did this wrong. No, this should be 1 plus 1, or 1 times 1 times 1. So, let's take a look. What am I doing? Though this actually gets a little bit icky because I think this just returns it. That's why this is so slow actually. I need to optimize this a little bit. Maybe, I don't know. I don't think, maybe that's not, well, the reason why this is so slow isn't just this, is that is that it's running this part. This part is a little bit slow, right? So maybe I have to do something like if I is in counter, if J is in counter, if K is in counter. This is ugly. We probably could have made it a numerator or something. Yeah. See, now this is much faster. But 2, 3, 3. Oh, I see. Okay. So I guess we'll just special case it out. We'll just do like J plus 1, K plus 1, and then now we can do this times 6, right? Because of 3 factorial for the whoops. 3 factorial for each of the permutations. Okay, so this one is right, but we didn't handle this case, right? So then now we have to figure out, and we could do it. Basically, the J case, right? So this is the or distinct case, and then now we have to see if yeah. So if count sub all right. This is a little bit yucky, but that's fine. If counter sub I is greater than 1, or if this is true, right? If counter sub I is greater than, I have to do the check first though. Okay, so if, oh no, maybe I could do this as part of the check, and this is so annoying to write, but I mean it's fine. But okay, if this is true, then let's do sum is equal to I plus J. We assume that J has at least 1, of course. Then now if sum of 1, well, we just do this again. Oh, in this case though, we don't need to do this, because if it is divisible by I, then it has to be, then in this case, yeah, there'll be 2 i's, which is already not true. So then we can just actually simply write this, and then we write total, we would do the math, it'll be counter sub I choose 2. So I'm a little bit lazy, so what was the, there's a function, right? Is it binom in Python? Maybe I'm mixing languages or something, I don't know, but yeah. And then yeah, it's still not done because I have to choose the other one of, if this is true, then S is equal to I plus J, and then if S mod J is equal to I is 0, then we do the same thing but for the other one. And I think that's all the cases. Actually maybe that's not enough. So we choose these 2, and then maybe I have to multiply by 6 still. I guess we could just multiply 6 at the end, maybe. What is the thing? Oh, I forgot the thing. Python binom function. Is it choose? Choice, maybe? I don't remember. I feel like I've seen this. Okay, maybe it is choose then. Okay, it is not. Choice maybe. I don't think I made this up though, right? Random.choice. Alright, let me look it up real quick. Binomial function. What is it's new, but I feel like I've seen it, but I don't remember it. Was it Python 3.10? Is it? I think. Math. Comp. Okay. So okay. Combinations, I guess. Okay, so sounds good. I think one thing that I'm going to see is that I wasn't sure that this was also going to be times 6 early on, so I think we just removed this and then multiply by 6 later, which is here, just for a slight optimization. But I mean, it's not really a big deal. But let's give it a submit. Hopefully, I didn't miss an edge case, or it's too slow, huh? 4. Oh, I have. Okay, I see. I mean, this is true, but I also have to check that si is not equal to 0. Whoops. I think I simplified it a little bit too much. I forgot the other case. I think the other case was something like 112 or something. I don't know why this takes so long. Okay, inconsistent results. Got it. Good. Thanks for. I'm not using C++ though. I feel like you could put an if statement for like if I use C++. But yeah, looks pretty okay. I think one thing that now I'm thinking about it is what is my submission time? I mean, I didn't really think about it that much with respect because I knew that this is fast. But I guess what I could do is also do something like like C keys is equal to counter.keys and then do it that way basically. For I is in C keys, right? But I mean something like this, but basically the range of right, so range of CK was it C keys and I, right, something like this. Just trying to minimize the number of things I have to rewrite, but J is equal to CKs dot NJ, right? I didn't fix it quite right, but give me a second. Because this has to be NJ plus 1, and this has to be NI plus 1. Is that true? That's actually interesting. I didn't know that. I mean, all we have to do is convert it to a list, but I didn't know that that's the case. Let's give it a submit again and see if this is much faster. Should be faster, but not by that much, so maybe I'm wrong. I do wonder, is there a faster way? I mean, I guess the faster way is actually pre-computing all the IJKs and then kind of do a lookup that way. I think that's a little bit cheating, but maybe not. I don't know. Because here we still have to compute this way, but it also throws away a lot that doesn't. So I don't know. Do people just pre-compute? No, people just did it the way that I did it. No, this is faster than mine, maybe? I don't know. Yeah, you could do it this way. That's the way that I was thinking of, that you can pre-calculate these. But yeah, a little bit sad about missing this one. I was thinking about it, but then for some reason I noticed an observation, but then I forgot to finish out the observation. Anyway, that's all I have for this one. That I'm going to take a shower and all this stuff. I don't know why you need to know that, but I'm letting you know. Anyway, that's all I have though. So hit the like button, hit the subscribe button again, and I'll see you soon. Stay good, stay healthy to good mental health. If you're doing the contest later, good luck, and wish me good luck. I'll see you later. Bye bye.